Hello guys, here Gabi again. Today we are going to talk about query optimization and indexing in SQL Server. Let's say we have a problem with slow queries in production that are never just a slow query. They turn into high CPU, massive logical reads, thread pressure, timeouts, and suddenly our microservice is the bottleneck for everything upstream. Okay, so in this video I will try to reach to you to tell you how we could use SQL Server performance metric first, then the actual execution plan, and only then changes. Okay, we will cover what indexes are, how SQL use B trees, B plus trees, clustered and non-clustered indexes, scan versus seek, how the optimizer chooses plans, and so on. Okay, so if we jump straight to add an index, for example, without checking the logical reads and read the actual plan, we are basically guessing. Okay, so and guessing in production is very expensive. There is an approach where we could go through a slow query in the same order. We have a metric, we have an execution plan, and then we make changes. Okay, the metric, the execution plan, and the changes. The execution plan is the actual plan. The changes are to make a query, to make indexes, parameters, hash, and so on. SQL performance problems are rarely about one magic tweak. They are about understanding what's expensive. Are you doing a scan when you expected a seek? Are you reading way more pages than you think? Is the optimizer estimating 10 rows but returning 10 million, for example? Is a cached plan great for one parameter value and terrible for another? If you can't answer those, every change is a gamble. So let's walk through the full model and then the practical fixes. How we could tackle a slow query. Okay, step one with metrics. We can confirm it with real data. We can know the duration of the query, for example, with average and doing a P95, with CPU usage, with logical reads, and frequency, how often it runs. Okay, because a query that is slow once a day is not the same as a query that's kinda slow but runs thousands of times per minute. Okay, so that's the first step. The metrics through P95 average, we check the CPU usage, the logical reads, and the frequency of execution. Okay, step number 2, the execution plan. Scans versus seeks, expensive operators, estimated rows versus real rows. Step number 3, changes. After that, we seek projection, filters, or ordering, indexes, parameters, and cache behaviors. Okay? So, first, go from the base. What is an index and why it matters? Okay? An index is an extra data structure that lets SQL Server find rows fast without reading the whole table. Okay? It's like the index of a book. If we have no index, we scan all the table. In a book, if we don't have an index, we need to go through all the book or by memory to get what we want to search. But if we have a correct index, we do a index seek. Okay, no index, double scan. Index, index seek. Okay, it's literally like the index of a book. We jump directly to the page instead of reading every page until we find the proper one. Okay, so how an index actually works internally. People usually ask, is a try? No, SQL Server primarily uses B plus trees. A B plus trees is a balanced tree where the searches are with the complexity of log n. It has leaf pages that are linked, which is great for range queries. So we have B plus trees that are the internal structure of the indexes. So the index is an additional data structure that help us to do this search. Is a B plus tree with is a balanced tree with a complexity of log n. Okay, and this matters because seeks are fast. The ranges performs very well, and the order of the columns matters. Okay, this is very important. The order of the columns in the index matters. All right, so we have two types of indexes in SQL Server: clustered and non-clustered. All right. The clustered index defines the physical order of the table. The table is the index. Only one clustered index per table. This is great for primary keys. It's great for sequential ranges like dates or IDs. Example, an ID as the clustered primary key. On the other hand, the non-clustered index, a non-clustered index is a separate structure that points to the clustered index. So the non-clustered index is another structure that points to the clustered index, okay? Or to the heap if there is no clustered index. We can have many non-clustered indexes, okay? It has key columns via include, and real examples could be customer ID, commerce ID, and so on. Okay? So, how SQL Server decides to use an index? SQL Server does not pick an index. It picks the cheapest plan based on its cost estimates. Okay? It looks at estimated cardinality, index selectivity, statistics, and the cost of input-output versus CPU. We have a key rule. If returning many rows through an index is more expensive than scanning, it will scan. If the index is selective, it will seek. That's where we have seek and scan. Okay? I repeat. If returning many rows through an index is very expensive than scanning the whole table, it will seek. If not, we are going to do the seek. Okay? So what is scans versus seeks? Versus seek. An index seek is when we point lookup to a small range. Okay? The index is aligned with the where. The index scan or table scan, because the table itself, as I said before, is an index, has many rows and the index not selective enough or not aligned to the predicate. Okay, this is why having an index is not the same as having the right index. Okay, we have other stuff that we could cover in other video. That could be parameter sniffing as a classic problem, how we cover indexes, and then we have the practical query optimization rules, that is select only the needed columns, we apply filters early, we paginate correctly, we avoid select asterisk, we use as no tracking for read-only queries, and we design indexes aligned to real query patterns, not theoretical ones. So, repeating, the practical query optimizations are select only the needed columns, not the whole table. Okay, we apply filters early first. We paginate correctly, for example, with skip and take. We avoid select asterisk, and we use as no tracking for read-only queries. This is very important. Which are some query optimizations? We use the as no tracking for read-only queries. We avoid select asterisk. We filter first. We use first. We use skip take for pagination, and we only select the needed columns. Okay, and the algorithmic complexity in this matter at a high level when we do a seek in a B+3 in SQL Server is log n, and the scan is on, because the index is a table and doing a scan is a table, and it could go through all the table. Okay, that's the difference between fast and low, and it degrades linearly as data grows. Okay, so closing by as a summary, we need to confirm the metrics with P95, average, CPU, and metrics. Okay, logical reads and frequency. Then we have a plan, scans versus seeks, expensive operators, estimated versus real rows, and then we apply the changes that could be the query optimizations as we said before, projection, filters, ordering, indexes, and parameter cache strategies. Okay, so I hope this helps to you to understand a little more better about indexes that could be clustered, non-clustered, the query optimizations possibilities, what is an index, and so on. So thank you, and see you next time. Bye bye.